Good morning. I'm Ajay Issac, and welcome to the Infosys Prize interview with Professor Hari Balakrishnan, the Engineering and Computer Science Laureate of the Infosys Prize in 2020. Good morning, Professor Balakrishnan, and thank you for joining us today.
Thank you for having me.
Your Infosys Prize citation reads, Infosys Prize 2020 in Engineering and Computer Science is awarded to Professor Hari Balakrishnan for his broad contribution to computer networking, his seminal work on mobile and wireless systems, and for commercial use of mobile telematics to improve driver behavior and make roads safer around the world. Can you break this down and explain it as you would to a 10-year-old?
I'm going to try. It's actually quite simple. There are two strands of work that I've been able to do over the last 25 years. One is an area that I helped to create called mobile sensing. The idea here is using sensors like position GPS sensors and accelerometers and ways in which you can measure movement on mobile devices like your phones, Android phones and iPhones, to be able to understand how people are driving, to be able to understand how good road conditions are, to be able to understand traffic conditions and so on. So that's one area of work that we helped create. And we started working on this 2004 and 2004. There were iPhones and Androids, and we were able to develop some early pioneering technologies. And the other area of work is on the internet itself and on wireless networks, which today are the way in which people connect to the internet. And I and my collaborators have done a lot of work in making the internet and wireless networks much more reliable, much more resilient to failures, and to help applications perform really well.
Thank you so much. I'm pretty sure that's made it way simpler. And the work that you do, I'm pretty sure, is way more complex than those simple words that you use. But Professor, in nearly 3 decades in this field, you've studied and worked with so many brilliant minds. You come from a family of academicians. Professor Balakrishnan, can you tell us who or what inspires you?
It's a great question. And there's plenty of people who I derive a lot of inspiration from. A lot of them are my students and my collaborators that really, my colleagues and collaborators, students make me want to be better. But if I really were thinking hard about it, I would say that 4 people have made a big difference and continue to inspire me. My parents, who are both researchers, they're both physicists. And I think they have, over the years that from when I was a child, research was always in our family. They've been researchers throughout, and they've been a big inspiration to me. And in particular, my mother, who has actually had a very challenging career path, being a woman scientist from the late 60s or the 70s. So that's been a big inspiration. And the other 2 people are my grandmother and great-grandmother, who I lived with them, and my parents, and they really showed me a lot of, they were the inspiration. They were the reason I am who I am today. So I think those would be my core inspirations.
Thank you so much. Definitely the work that, and all of these people that you've mentioned, they've done some pretty impressive work in their own specific fields. Professor, what got you specifically interested in mobile telematics? What led you to start the Cartel project in 2004?
When I joined MIT after my PhD at Berkeley in 1998, I had done my research in wireless networking and understanding how to make wireless protocols that are used for communication between applications better on wireless. And this work predates the existence of Wi-Fi. Wi-Fi came a little bit after the work that I'd done on my thesis. And in the first few years at MIT, one of the projects I worked on was a project called Cricket, which is an indoor location system, an accurate indoor system. Inside, GPS doesn't work. If you're outside, GPS works. And between 1999 and 2004, I developed a technology called Cricket, which frankly was very interesting technically and an enormous amount of fun to work on. And that's when I learned about sensors, because we were producing a system to get accuracy to within 3 to 5 centimeters indoors. And we were working with devices that today, you look at handhelds and iPhones and Android phones and so on, and we were working with these computers that we were able to carry in our hand and allow people to understand where they were inside buildings. And it was just hugely fascinating. In 2004, I had this idea that sensors on mobile devices, because we built those sensors, could now be put into vehicles. And I was just observing that my commute from the suburb that I lived in outside of Cambridge, outside of Boston, was taking a little bit longer and longer and longer. And I thought we should do something about it. And my colleague Sam Madden had graduated also from Berkeley and just joined MIT. So we started thinking about it, and he had worked on sensor networks as well, static sensor networks. And we said, why don't we just put these things in our cars and just try to measure what's happening to traffic and what's happening to the roads. Many of the roads around Boston are not in very good condition. I think people in India can relate to that. And it turns out it's a similar issue in many, many parts of the world. And so we worked on this line of work that led from understanding a very simple question: why is my commute getting longer and longer? To what's wrong with all our roads? Can we figure out how to develop technologies using these sensors on vehicles to just automatically help cities figure out how to go, which road potholes to fix? Because there's lots of roads in bad condition, but if people are actually driving over them and it's impacting the cars, those are the ones you have to fix first. Then that led me into thinking about safety. So it started because of a very simple and provocative idea. Let's just put sensors on vehicles. And I just want to explain why this was provocative, because at that time, this was not very scalable. It was not economical to do it. And a lot of people told us, we should just put sensors on the sides of the roads. In fact, that's what governments were starting to do, lining all the highways with sensors to measure moving vehicles. And we just took a simple idea and turned it around. So it was driven by intellectual curiosity and, frankly, just the fact that my commute was getting longer and longer.
Thank you, Professor. And definitely your research and your work has created a huge impact. We've come a long way. Going back to the roots, your research and technology use a very interesting combination of both behavioral psychology and mobile telematics. Can you tell us what led you to use this interdisciplinary approach?
Yeah, let me first explain the word telematics, because people might not quite understand it. It comes from tele, which is distance, and matics, which is a form of study or measurement. And it's come to be applied today to devices in mobile assets, whether they be vehicles or people, to be able to measure movement, to be able to measure patterns of mobility. And in the academic community, this used to be and is still known as mobile sensing, but telematics could be viewed as mobile sensing plus analytics, or maybe even artificial intelligence on that data. Around 2009, coming off of the recession was going on at that time, and we had a number of academic successes with our research project and won awards for the research. But in addition, newspapers like the Wall Street Journal and the Boston Globe and other technical magazines had written about this project. And there was an article by the chief technology officer of the US Postal Service that said, we should take this type of cartel type of technology and put it on all the postal vehicles to automatically measure road surface conditions, because we developed this technology called the pothole patrol. And that really got me excited, because I had been looking at ways to try to commercialize and bring to the real world this cartel technology, but never really thought about what it would be. And then road surface condition was written by this article on the Postal Service. Actually, I think it was written as a way to monetize and provide revenue for the postal system, because now cities could pay for that. And then I started learning about insurance, because I was thinking, who wants the roads to be better? Who wants driving to be safer, which is what our technology can provide? And I learned that insurers were starting to put in more expensive devices in vehicles, both in Europe and in the United States, and these were quite expensive. And this research, we've done all this with inexpensive devices. Today, it's known as Internet of Things. At the time, it was just known as sensor computing in the academic community. We've done this with mobile devices, with phones, and with inexpensive IoT devices. And that led to this idea that it's a win-win. If we could provide scalable technologies that can reach a mass market of millions and millions of drivers. Today, there are 1.4 billion vehicles on the road. At the time, in 2010, there were about 1 billion vehicles on the road. So we've seen a 40% increase in a decade. I said, we got to scale this out. It could be done with mobile. But then how do you get people to be better drivers? And throughout the history of safety, it has always been punitive. It has always been that, you drive badly, maybe the police stops you, or you get into an accident and bad things happen. And it was an interesting idea to think about saying, can we incentivize safe driving? Can we make people want to do things that make them better? And I think that this is an idea that around that time and a little before had been looked at by economists and behavioral scientists. And I was very intrigued by it. And we had some partners when we commercialized it into our company. We had some commercial partners very interested in driving this direction. And that's what happened. So I do believe that safe drivers are made, they're not born, that almost everyone can become a safer driver. It's easier to drive and drive well than it is to ride a bicycle or swim or do a lot of things that people do. So that's really the motivation.
Thank you so much, Prof. Talking about motivation, just going back to another question. If you mentioned how the vehicles on the roads have grown from 1 billion all the way to the 40% increase all the way to 1.4 billion right now. So has your company, so has been your research. But what drives you to come back to the same problem day after day?
Fundamentally, I think the desire to make an impact, whether it be intellectual impact, which is what researchers do, we produce ideas, or real world impact. That could be done through ideas that make it into standards or open source software or commercial systems. I think that's number one. What really drives me is just this desire for wanting to make a difference to other people. And I don't want to sound like, I'm only driven by wanting to help people and so on. I like to help people like everyone else does. But I think a lot of the impact is by the ideas that we produce. If we influence other researchers, other students to do things, I think that's a big form of impact. The second thing, the driver, you asked about visiting the same problem again and again. And in many cases, that is true, that the core problem remains the same. But, in computer science and artificial intelligence, we work in an exciting field where because certain underlying technologies change and because users' expectations of that technology gets harder and harder to meet, you can go back to the same problem and the underlying technology space has changed so much that you can come up with a very different type of solution to the same problem. So it actually is something where the same core problems remain open for many, many years, if not decades, because the underlying assumptions behind the problem have changed. So I think that that is one reason why some of these fundamental problems, they get solved in a certain context, and the context behind the problem matters. As an example, today we have several billion phones, which didn't exist 15 years ago. So if I were starting an academic project, imagine we hadn't done the Cartel project, none of this had happened. Today, I would start front and center with smartphones. But at that time, we didn't. But if you start front and center with smartphones, what you do next becomes completely different. So if you now think about what the world is going to be 10 or 15 years from now, we're really looking at something that is, we're going to be inventing it, all of us in the community, but none of us can really predict where the world is going to be 10, 15 years from now from a technological standpoint. And so I'm pretty confident that many of these problems will remain open in some form or another in a different context.
You'd earlier mentioned about cricket and your first project, and true to your Indian origin, in fact, you've been a very passionate cricket fan. The sport, in fact, the system that you earlier mentioned was named after the sport itself.
Yes.
Balakrishnan, if not research, what alternative career would you have considered?
I really did want to be a cricketer, but I think that, in the 80s in India, it was, especially from the background that my family with our research background, I don't think it was a very pragmatic possibility. Looking back, I was not bad. I did play quite enthusiastically in both school and IIT in college. And then when I came to graduate school, I played for 4 years and there was a league in Northern California. But I was not anywhere near the quality needed. But, sometimes you wonder if I could have, with the right training, coaching background, I don't think I would have been as successful in cricket as I am in, as it happens in computer science research. But I think that would have been an amazing thing to do. I think I've learned a lot from playing cricket over the years. It's taught me about teamwork, because cricket is, although we are very, we always pay attention to the individual and the statistics, but if you look at great teams that win, They win because they're not dependent on a small number of people. They have a lot of people who can fill in and do the work that's needed when certain other people don't succeed on any given day. The other thing that it's taught me is something that is very important, which is that it's important to set goals but not make them be very rigid. I like very fluid, high-level objectives, but then really use those to motivate very detailed kind of day-to-day processes. Even in research, just sort of think about, okay, what is it I want to accomplish today without really getting daunted by some high-level specific objective, because research is often a series of failures with occasional successes. And so if you're very hung up on defining your success or failure with a very rigid objective, it doesn't work, because research is about, if you can't solve a problem, change the problem. You can do that. It's not like an exam in school where if you don't solve the problem, you don't get a good grade. Here, you can see what you've done and then change the question. So that level of flexibility is important. And I think in cricket, people have that in many team sports. You often try to change the way in which you approach things by changing the problem and really focusing on the methods and process. And outcomes will then come if they come.
Absolutely. We don't know, maybe the world missed out on a brilliant cricketer, but
it certainly missed out on, I doubt that it missed out on a brilliant cricketer, but it's something that I just am amazed at how they're able to do it. It requires a tremendous degree of commitment.
Absolutely. But in fact, I believe the world got an amazing computer researcher in return. And your work has pretty much created a huge impact so far. But looking back, Professor, what do you see as your legacy in your field of work, or looking ahead, what would you want it to be?
I mean, honestly, I really believe, I don't know if it's going to be true, but I really hope my best work is still to come. I mean, that is really the honest feeling that I have. I think that, there's been some impact intellectually with the papers that my students and collaborators and I have written, and with some commercial impact that we've had. But, I'd like to think that we are just getting started. I think it's not appropriate for me to talk about things like legacy. I really believe that we're on the cusp of some very exciting things this decade in our field, with the way in which sensor technologies are proliferating, modern techniques for drawing inferences from that data, whether it be with artificial intelligence or whether it be with signal processing or statistics or a combination. And the idea of not only drawing inferences in a passive way, but in systems with feedback where you can control, where you can send information back that causes the participants, the entities in the system, to change their behavior, whether it be computers changing their behavior or approach or humans. That is an entirely unknown area in many ways now, especially when you look at the convergence of more modern AI techniques with feedback and control. So I think that I sincerely hope that there's more work that my collaborators and I can do that will be even better than whatever has happened so far.
Absolutely. And we hope the best is yet to come. We are so sure if you were. Professor Balakrishnan, India, as you know, has consistently registered one of the highest number of road fatalities in the world. Indian road safety system continue, like how you mentioned earlier, it primarily works on penalties. That would be the sticks, a system that you have vocally opposed, that you consider to be hugely ineffective to tackle, say, suboptimal driving behavior. How do you foresee your work being applied in India?
I think it's very applicable. I think that the idea of incentives to augment penalties is good. I mean, again, I want to be careful that I don't say that laws and regulation and penalties are bad. I just think they are ineffective in this case. I mean, take phone distraction. It is the single biggest cause today for road crashes. Just inattentive driving. People are distracted by their phone. This is a worldwide phenomenon. But, every trip to India since 2013, 2014, I've had many, many trips, and people are on their phone, on their scooters, on their bicycles. They're like holding the phone like this while driving. I mean, it's just extraordinarily dangerous. And it's not just India. It happens in many places. And I think that the trouble with something like phone distraction is it's very easy to be distracted by the phone, but very difficult for a third party looking outside, like a law enforcement, to know whether you're really distracted by the phone, because you can keep the phone on your lap and kind of be tapping on it. It's very difficult to enforce. So education and positive incentives and feedback can make a difference. And we've seen this. I'll take South Africa. We work with a partner in South Africa, and we've done this for many years. We have made a tangible impact there. I think that if you look at the people who use our technologies, the fatality rate is lower by about 60% than people who don't. And I've been to South Africa. It's not that different from India in terms of a lot of the economic conditions and education, diversity, and things like that. And these technologies do work. I'm very optimistic they can work in India. India has a number of other challenges because the roads are dangerous for a variety of other reasons. There's lighting issues, there's night driving issues, and so on. But all of those issues are understandable with telematics and sensing technologies. So I think that people will respond to positive incentives, and people will understand that it's a win for them, a win for society.
We're hopeful as well. We look forward to seeing your system implemented here soon. Looking ahead, Professor Balakrishnan, how will technologies like 5G, Internet of Things, and vehicular automation affect your devices?
The story of technology has always been one of rapid change. The typical hardware and sensing technologies change every few years. There's an evolution. It's revolution through evolution is the way I like to think about it. And I think it's a good way to plan the way in which you approach a career in research or commercialization in the computing industry, that you achieve revolution through evolution. The next decade is going to see many of these trends that you're talking about. It's going to allow for instrumentation and telematics to be delivering higher volumes of data in real time. But a key point to note is that the amount of data we can gather, in my opinion, for that over that 10-year time frame is going to far exceed the capabilities of the networks. Because if you quadruple the capacity of your network, let's say, we can show you ways you can increase by 8-fold or 16-fold the amount of interesting data. So we're going to really be looking at doing more processing, more inferences on the devices themselves. Some people call this edge computing. But then we're going to be able to send more data, often in semi-real time or real time, to inference engines in the cloud, and then start to affect feedback down back to the systems. The other thing that's going to happen is increased automation in vehicles. And by the end of the decade, we're going to see a more serious penetration of autonomous vehicles. In a world where there's more automation of vehicles and increasing degrees of autonomous driving, all of the assessment, not just a small part, but all of the assessment of the risk of those vehicles is going to be based on telematics. It's going to be based on data. It will no longer matter how old you are, how many years of experience of driving you have, what your economic status is, etc., in terms of your likelihood of entering a crash and flying a plane. You're going to be looking at it in terms of how does that vehicle react in a real environment with other vehicles that in a situation that has never been seen before. And to do that, you need observable technologies that scale and are able to evaluate, number one, the quality of the sensor data that the autonomous vehicles are collecting. Number two, how good are the reinforcement learning algorithms and other machine learning and inference algorithms that the vehicle is adopting, and how good is the quality of the software. All of that becomes a computing challenge and a challenge of applying artificial intelligence. So it's going to be based on data. It's going to be based on an observation of that vehicle and the dynamics of that vehicle in very challenging, unforeseen real-world conditions. And that's why I think that the types of research and technologies that we're building today in this field are going to become even more important as we head into a more autonomous and a more automated future for driving.
Thank you. Something really interesting in what you just said was how technology is evolving so rapidly. And in fact, your technology has always been one step ahead of commercialized computer technology. You pioneered in mobile embedded big data tracking on Nokia phones much before iPhones and Androids and fitness devices. You placed your bet on IoT way back in 2014. So what, in your opinion, is the future of driving technology?
So I think that one thing that seems fairly clear is that there's going to be a lot more video, initially with commercial vehicles, over time with personal vehicles that we all drive. In fact, all of the vehicles today come with a number of cameras already. And I think that it would become quite natural over the next 5 to 7 years to see a lot more inference drawn from that video about how driving is really working. The other important aspect of it is that it is no longer going to be just about how safe is the vehicle and the people within the vehicle, but it's critically important to look at safety of the others in the environment, pedestrians, bicyclists, people who are running, people in two-wheelers, etc. And I think that if you look at it more holistically, we're going to see that those are not going to be automated. People are still going to be walking and riding their bikes, and they're going to be distracted possibly by their phones. So we need a more holistic solution for safety that goes beyond just keeping the people inside of a vehicle safe. Obviously, that's going to be continuing and happening. We talked about increasing levels of automation in the vehicle and technology space, and that is going to continue. And I think, but I think it's important to realize that this idea that they will be infallible is very unlikely. We can't even make our video conferencing system, our email systems, all of these software systems that are considerably simpler than what it takes to build a really good vehicular computing system, right? We can't even build a highly reliable, robust conferencing system. I've noticed even on this call today, we've seen a couple of glitches that happen. We can't afford things like that in a world where these vehicles are making a million critical decisions a year. Imagine you make a million critical decisions a year in technical software. It means you can't have an error. If you have an error rate of 1 in a million, which sounds really great for software, well, it means you're having one incident per year in a vehicle. Well, that's not good enough. So I think the scope of this problem is considerably harder to achieve infallible software systems and AI systems. So there's always going to be an important need for understanding and improving and understanding and measuring and improving and using that to guide our decisions. And the other thing that's important is that control becomes important. Right now, a lot of AI is used for drawing inferences and then insights, but it's going to start being used for exercising control, whether it be in real time or non-real time. But it's going to start to change how the entities in the system adapt. So that is something that we see, and we do a lot with human engineered systems. And when we start to apply AI to that, to combine that with human ingenuity, we're going to see a lot of very exciting challenges ahead.
Thank you, Professor. This technology that you just spoke about, and be it in the future, be it the system that you're using right now, it's all fueled by big data. And with stringent local and intergovernmental data protection laws, we had GDPR in 2018, CCPA in 2020. Moving forward, how will these data protection laws affect Cambridge Mobile Telematics and your other big data research?
We are already privacy front and center of everything we do. And our company, Cambridge Mobile Telematics, we view privacy as not just a regulatory requirement. We actually view it differently. We view it as a business imperative. We view it as, frankly, a business advantage for us, because compared to many other players in our field, we place privacy front and center. We have a very simple data sharing policy, which says we don't share data with third parties, period. The company is not in the business of monetizing the data through advertising or through data sharing and any of that. It is in a very simple business model where someone like an insurance company uses the technology to offer services for drivers, and only we and the insurance company see the data. In fact, in many cases, the insurer doesn't even see a lot of that data. We become the data controller. And our policies are very, very simple. We don't share the data. We have been conforming to those regulations from well before they were even regulations, and certainly GDPR and CCPA and things like that. So I think that it is critical for the industry at large in our field to start to take or to continue to take privacy extremely seriously. There will always be some nefarious actors in the industry who do things that are required because they don't have a solid business model, and so they are reliant on selling the data. And I think that has to stop. So I don't think it'll affect us from a pragmatic perspective, because we've actually been talking about it from the beginning and doing things about it in the beginning. And this predates the company. In 2008, 2009, together with some collaborators and a student, we wrote some papers on how you should be thinking about taking location-sensitive data, and how can you run secure private computations over that data to draw inferences without revealing the detailed information about location. So I think we're very much behind and supportive and encourage the focus on privacy, because ultimately strong implemented privacy policies will give users a lot more confidence that the data is only going to be used for the purposes that they believe it's going to be used for. Nobody wants unpleasant surprises.
One of your interviews, you once said, one of the talks, you said, your customers, you view them as partners in view of the data sharing. And I believe that's worked out for you. Professor, coming back to research, what would you say to aspiring researchers, especially in another frustrating year of the pandemic, where we're seeing massive changes in the format of research and academia and in general?
I think there are two things that are important. And the way I sort of think of it in simple terms is there's a set of things that you're interested in. So that's a circle. There's a set of things you're actually good at. It's another circle. It's really good to be working at the intersection of the two circles. I'll give you an example. I started my career as a theoretical computer scientist. As an undergraduate, I was really interested in theory, loved it, loved reading papers on algorithms and theories and proofs and so on. And that's how I started. In fact, I think I even applied to graduate school for PhD programs in many universities as a theory student. But I think toward the end of the undergraduate career, I realized that while I was very interested in theory and I enjoyed reading it, it was more of a struggle for me to prove my own theorems or to prove conjectures. I was good at counterexamples, but it was a struggle. I was able to do it, but not as good as I think one needs to be world class. So, there's a set of things I was interested in. Then there were other things that I happened to be good at. And, it took me about a year or so of graduate school to understand that intersection. And it turns out the field of network systems, networking and mobile, has that intersection where there's enough principles and theoretical underpinnings, but there's a lot of more systems-oriented thinking and protocols. And so it's a good intersection. So if I'd stuck to only what I was interested in, I might have not been able to have the impact that I otherwise did. So I think finding that intersection is useful, and it takes some time. You have to be patient through the process, but also ultimately be honest to yourself, because that's the only thing that really matters. With respect to the pandemic, it is an incredible challenge. I've been telling my students that they really have to not be too harsh on themselves. So research in our field especially, is a social enterprise. It is not an individual enterprise. It is not like someone goes into the room, locks the door, and 6 months later or a year later or 5 years later comes out with a result and tells the world. That's just not the way it works. It's very, very social. So I think there's challenges right now. Social isolation is a big problem because we don't get to spend time physically with each other and whiteboarding things and so on. On the other hand, I also think that there's an opportunity. I think it's a lot easier to give talks right now because we can do it online through video. I think that actually we've gotten used now to be able to communicate through wireless, through the internet, through these media that we have right now, because we all have Wi-Fi and then there's internet and we can do this. And there are tools now to do shared whiteboard. Is it the same as meeting you face to face right now, Ajay? No, it's not. But what it is an opportunity. We can now, young researchers, especially at the nascent stages of their research careers, can essentially invite themselves or ask to be invited to group meetings of other people, more senior people in the field, if they're working in the same sort of things, because the overhead now is very easy. Previously, to invite someone, you'd have to spend a day or two, take them to lunch, take them to dinner. It's an overhead that takes a lot of time. You got to arrange for now. It's you join a meeting, you talk for an hour, have a discussion, go on with your day. So I actually think outreach is easier now, even though everything else has become hard. So the two lessons are, number one, don't be too hard on yourself. It is a challenge. You just have to kind of, the hope is that we will come out of it, but just try to stay very positive. Try to, interact with people. And number two, use the online mode to have more online outreach, and engage with your peers. Even just communicating your research and getting feedback and giving other people feedback is the way to go. But I think on a very, very hopeful level, maybe a year from now we will be a lot more back to pre-pandemic. I was hoping 6 months from now, but I think India in particular is seeing some tremendous challenges, with the help of the whole world, but primarily through the resourcefulness of people in India, we can come out of it, and come out of it successfully. I have no doubt we will come out of it, but hopefully we'll do so soon and without too much more damage.
As we come to the end of this interview, I think we have a self-reflective question. How did winning the Infosys Prize impact you?
I was very surprised and very happy. So I'll be honest. You don't do this. You're not in this line of work for recognition, because if one seeks recognition and believes that's the goal, then you're only going to get failure. So you do the work you can. I felt really. I'll be honest. Look, I just felt happy. I felt like the recognition of one's peers in the field, and especially with the jury of very eminent people. They're not even my peers. They're really very eminent people. It is an incredible honor. I was excited to tell my students, who really deserve a lot of the credit here for my work, as well as my collaborators at both in the Cartel project and at my company at CMT. So I just felt, the initial emotion was surprise, and then immediately followed by happiness. I think that the people who really felt even happier than me and very proud are my parents and my grandmother and my close relatives, family. I think they just were excited about it, and it made me happy that my parents in particular, to see them so happy. So that's kind of the gist, and it came in the middle of the pandemic. So there's a lot of negative news. So at least on a personal level, it was very, very gratifying and an incredible honor, because I know how important this is, and how I would like to take the responsibility of it quite seriously and participate in outreach and communicate the excitement of research to everybody in India, and as well as the rest of the world. I think the area that I work in is very understandable as to what the impact is. But what I'd like to do is to be telling people the story of how academic research done for its own sake can have a practical impact. But even if it doesn't, how the ideas lead to other ideas that might eventually have impact. So I think there's a whole journey there that would be really inspirational for people to understand, and really try to communicate why research is important to support.
Thank you, Professor. In fact, one of the objectives of the Infosys Prize is to create role models in specific fields of research, and we're truly excited to have you on board in our nomination council now. Professor Balakrishnan, it was such an honor talking to you. Thank you for this thing. We had a little sneak peek both into the way that you think about research as well as the future of driving, we believe. Thank you so much for your time.
Ajay, thank you so much for interviewing me, and I'm deeply grateful to the Infosys Foundation for creating this award, and in so many different fields, and really recognizing top quality work across various fields, and at an even deeper level, using this to drive the excitement of research in India. And I know it's focused on India, but frankly, in India and in the rest of the world, I think it's having an impact. So deeply grateful to Infosys for doing this.
Thank you.
You're welcome.